Good morning all of you, and let's see this two beautiful question from geometric progression. Usually the recent papers of JEE Advanced and even IISCR, ISI and CMI is loaded with the field of basic number theory. Okay, so here is two such problems which particularly emphasize that idea. Let's start with the first one. X is a positive real number such that fractional part greatest x and x are in geometric progression, and we have defined a set S where n is natural number such that x raised to the power n is more than 100, so n cannot be which of the following. So let's start solving this. Since these three entries, fractional part of x, greatest and x are in GP, so from GP definition the ratio will be same, x by greatest. Since x is strictly positive, hence I can divide it, and hence we are getting greatest x square equals x times fractional part of x. Now we have 100% freedom on x because x is positive real, so it can give any answer. But greatest x will give only discrete output of integers, so we have a strong guardianship on greatest x. But the strongest guardianship is probably on fractional x, because fractional x will be sandwiched between 0 to 1. Although between 0 to 1 there are infinitely many many real numbers, still it feels to be strong guardianships. Okay, so with this minimum information, let's see how to tackle this question. For the sake of simplicity, I am denoting greatest x as I, integer. So x can be written as integer plus fraction, where f is fractional part of x. So the given equation can be written in this nice form. So now we have f square, I square is there, plus if minus I square is 0. From here, we can clearly find it's a quadratic in terms of f as well as in terms of I. Since to impose more strong guardianship, I am writing it a quadratic in terms of f. So f is minus b minus I plus minus root over p square minus 4ac will give root 5i by 2a. In fact, root over I square is not I but mod I. And since x is positive, so integer part is positive, hence I can write like this. अब यहाँ से clearly f is from 0 to 1 by definition of fractional part, so negative value will be discarded, so the only possibilities for this to holds true will be minus I plus root 5i by 2. So we have got a nice expression for fractional part of x. Let's see what we can do about this. So यहाँ से we can write fractional part which is I times root 5 minus 1 over 2. This belongs from 0 to 1. So that gives me I times root 5 minus 1 by 2 will dance from 0 to 1, implies I will dance from 2 tie root 5 minus 1 to 0. And virtue of this I can rationalize root 5 plus 1. This guy is going to be 4. So root 5 plus 1 by 2. Now root 5 is 2 point something plus 1 by 2. So that gives 1 point something. So integer between 0 to 1 point something, only possibilities of I is 0 and 1. Now I cannot be 0 because I0 makes fraction part of x0 and hence x0. So that is already discarded. So the only possibility is I equal to 1. Now with I equal to 1 over here, I'll get fractional part as root 5 minus 1 by 2 and I equal to 1. That gives the number x as I plus f, and this becomes root 5 minus 1 over 2 plus 1 root 5 plus 1 by 2. Okay, so we know there is a unique positive real number such that this 3 quantity will be in JP and that x will be root 5 plus 1 by 2. But still, the problem is not over because I have to find n belongs to natural number such that this to the power n will be more than 100. Now of course, if I'll take n to be too large, because you know this quantity is going to be 1 point something to the power n is more than 100. So if I take n, let's say too large, infinity, then definitely it's going to be more than 100 because it will merge 1 minus x something to the power n will go to infinity when n is infinity. So यहाँ से you can see 1 minus s at 0 it will be 1 and it will increase, strictly increasing. So there will be threshold limit, let's say y equal to 100. So after this all values of n will work, right? All discrete value of n will work. It means I'll find the minimum value of n such that it will reach to 100. Okay, or if it is more than 100. Now here the big problem is if I start approximating, let's say root 5 1.2 something, if you will give Okay, 2 point something actually it will come. So 2 point something plus 1 by 2. So even if you calculate the value of this root 5 up to let's say 2 decimal place, still by divided by 2 will have a little bit, you have to take 2 more decimal place in power and will give more drastic calculation. Okay. So that is another problem here. So what to do about it? And a way to go about it is to use, interestingly, Newton's sum. So here in observation, imagine an equation, a quadratic which is giving root 5 plus 1 by 2 as one of the root. So clearly, if I want to find a quadratic with rational coefficients, then the other root will be 1 minus root 5 by 2. Right? So we can find a quadratic x square minus sum of root, which is minus x, and plus product of root. So product of root is 1 minus 5 by 4, which is minus 1 equal to 0. It means this equation x square minus x minus 1 equal to 0 has two roots. Let's call as alpha and beta. Since alpha is the root of this quadratic, so remember I want to get alpha to the power n, means I want alpha square, alpha cube, alpha 4 and so on and so forth to check for the window. Since alpha is the root, so alpha will satisfy this, since alpha square is going to be alpha plus 1. Now I can multiply both sides with alpha again, so alpha cube is going to be alpha square plus alpha, and since alpha square is alpha plus 1, so it's 2 alpha plus 1. Similarly, alpha 4 is nothing but alpha cube plus alpha square. This you can see directly from here, because if I multiply this with let alpha to the power n minus 2, I get alpha n minus alpha to the power n minus 1 minus alpha to the power n minus 2 is 0. And we have a nice recursion on alpha. Alpha n will be alpha to the power n minus 1 plus alpha to the power n minus 2. And that's very surprising. So if I have a number alpha equals root 5 plus 1 by 2, you see its power n is related with this power of n minus 1 and n minus 2. It gives a feel of Fibonacci series as if n minus 2, n minus 1 and n is related. In fact, this term Tn is sum of its previous neighbor, right? Tn minus 1 plus Tn minus 2. And that's precisely the Fibonacci sequence. तो अल्फा 4 यहाँ से जो आ जाएगा वो आ जाएगा सम ऑफ इस प्रीवियस नेबर, so 2 alpha plus alpha 3 alpha plus 2. Just have to add these two. Again, if I add these two quantity, I'll get alpha 5, which is 5 alpha plus 3, and we can keep on doing. ठीक है. अब यहाँ से if you'll experiment, you can go to let's say alpha 6, alpha 7, alpha 8, alpha 9, alpha 10, alpha 11. So you have to see at what junction the power of alpha to the power n crosses hundreds. So let's take, for example, if I take alpha 6, I'll get 8 alpha plus 5. Okay. So alpha 6 value is 8, alpha is root 5 plus 1 by 2 and plus 5. If I have to check, this is alpha 6 actually. So you have to check for n equal to 6, is it crossing 100? So let's assume it cross 100. So we have 4 root 5 plus 4 plus 5, 9 is more than 100, which gives 4 root 5 is more than 100 minus 9, and 100 minus 9 is 81. So clearly it's two false. It means I know, because you see the square of this is going to be 80 and 81 square is going to be 6400 something range. So there is huge gap. It means alpha 5 will not work clearly. Similarly, you can check for alpha 6, alpha 7, alpha 8, alpha 9 by this Newton's sum. Okay. Now when I'll get to know where to stop. Now clearly, since this sequence is increasing, not too rapidly, but still is increasing. So maybe because alpha 6 will still not grow too much, so maybe you can try in some number like alpha 8. So you try with alpha 8. If it is too less, then try with alpha 9, alpha 10, alpha 11, and like this, somewhere between. If you'll try a little bit, which I'm leaving up to you because almost is done, so you will see for the first time alpha 10 will be the value which will cross 100. Okay. Hence the minimum value of n that will get is n equals 10. इसका मतलब 7 is not working, 8 is not working, 9 is not working, 10 is the minimum value. So that threshold which I was talking about will be 10. To 10 pe it will cross this value. It will not give an integer. And more than 10, if you will take any natural number, definitely it will be more than 10. So I hope you enjoyed this question, and it was a nice question. Let's try the second one. It is in fact more interesting. So S A1 comma R denotes geometric progression with first term A1 and common ratio R, such that the first term belongs to natural number and common ratio belongs to rational number. Usually the problem in AP set by J Advanced was having this flavor. So I tried to create a similar problem here. Okay, this I've incorporated even in my book, which I'll put on YouTube once it is released. such that the sum of a1, a2, a3. What is a1, a2, a3? They denotes kth term of geometric progression. F is the set of all such GP defined above. So there can be infinitely many GP whose like sum of terms will be 19, such that first term is a natural number. तो ऐसा तो हो ही सकता है, ठीक है ना. And common ratio is like irrational defined above. Then true statement is how many such GP is there in the set, and option C. Now of course, if you want to try this problem in the examination hall, the best way to start is option C, क्योंकि यहाँ पे it's just about understanding the problem. It shows like will the first term 4 and common ratio 3/2 will be the part of this. तो चलो इसको try कर लेते हैं. If first term is 4 and common ratio is 3/2, so next term will be 4 into 3/2, so that will give you 6. Again 3/2 will give you 9. Again next 3/2 will give 27/6 से 3/2 will give 9. Okay, so let's say first term is 4. If I multiply with common ratio of 3/2, will give this to be 6, and the next term will be 9. Since we have 3 terms, a1, a2, a3, clearly you can see there is some 4 plus 6 plus 9 is 19. So clearly option C is correct. Now the next question is, there exists some a1 comma r so that a1, a4 is 24. Oh, nice. It means like there will be some, let's say GP a1 with a1r square, a1r cube. So a1 and a4 product is basically a1 square and r cube is 24. So do you have some rational number r and natural number a1 such that their product is 24? ये possible है कि नहीं if the sum of first three terms is 19. तब इसको find करना explicitly will be difficult, right? So let's start now a general procedure to attack this problem. Let's take the first term is a. So here we go with the solution. The second term is AR and the third is AR square. That gives you 19. Remember, A is natural and R is rational. Okay, as described by the question. So यहाँ से we'll get R square plus R plus 1 minus 19 by A is equal to 0. I can divide by A because A is not a whole number. A is not 0. Now clearly, now we have a strong guardianship. The first guardianship will be D is greater than or equal to 0. That is necessary because for R to be real root. But we don't want only real. Also we want more strong window of rational. Right? Okay. So first let's check for D greater than or equal to 0. So D greater than 0 will give B a square. 1 minus 4AC. 1 minus 19 by A. This should be anyway greater than or equal to 0. It's necessary condition. Of course not sufficient. So 1 minus 4 plus 76 by A is greater than 0. So 76 by A is more than equal to 3. And that gives me A is less than equal to 76 by 3. And that gives 25 point something. So the value of A that I have to look is from 1 to 3 till 25. So this is a set from which I have to select. Now clearly it will be too lengthy and traumatic experience to check from all this. So let's put some strong guardianship. Okay, now a strong guardianship will be R value is minus B, so which is minus 1 plus minus root over B square minus 4AC, which is 76 by A minus 3 by 2A. Now if R has to be rational, if R is rational and you know A is natural, so one of the necessary condition again will be, again that is not sufficient. Okay, one of the necessary condition will be this has to be perfect square. अब यहाँ पे if this becomes perfect square, that will be sufficient in itself because R जो होगा वो हो जाएगा rational number. ठीक है. Now have they mentioned it's positive rational or negative rational? No. So that they have not mentioned. So R can be, common ratio can be negative also. We can have GP like 1 minus 1, 1 minus 1 and so on and so forth. ठीक है. If I make sure like 76 by A minus 3 is a perfect square. Okay, then definitely we can tell all will be rational. So under what condition it will be perfect square? One way is now you filter from 1 to 3, 25 all the way around. For example, if I'll keep let's say equal to 1, I'll get 76 minus 3 which is 73. Now this is not perfect square, so clearly that is wrong. Next I'll keep let's say A2, so A2 will give 2, 3, 38. 38 minus 3 is 35. That is not perfect square, so that will not work. So like this, if I keep on doing, it is lengthy. So यहाँ पे we can again be smart. I know if 76 by a minus 3 is some perfect square, like say some rational number square p by q whole square. So there are two possibilities. One possibility is a divides 76, because if divides 76, then this quantity will be an integer, and if it is an integer, we'll check if it is perfect square, because again just integer is not sufficient condition, because let's say if this becomes 5, so still will have root 5, so in that way q is not rational. So if a divides 76, that will give 1, 4, 2, 19 and 76. These are the probable options. Or a itself becomes a is perfect square. Why? Because if we'll take LCM 76 minus 3a by a, suppose if a itself become perfect square, तो फिर इसका रूट आने का possibilities है. So there is possibilities like let's say a becomes 4 or 9. So under that condition a also becomes perfect square, and definitely it belongs to irrational numbers. Okay, this can be proved in a more rigorous way also, लेकिन यहाँ तो I hope you have understood like these are the only possibilities. Moreover, we have to scan down through this window. ठीक है, so 142 1976. My other possibility is perfect square. Now perfect square from that window till 25 is 1 square, 2 square, 3 square, 4 square, 16 and 5 square 25. So finally I have to just check from this window of 1, 2, 4, 9, 16, 19, 25 and 76. I have to check for 1, 2, 3, 4, 5, 6, 7, 8 value. Out of this I have just checked for 1 is not working, 2 is not working. Okay, so let's take now a equal to 4. If I'll take a4, I'll get 76 by 4 minus 3. So this quantity becomes 19 minus 3, which is 16. So indeed this works. So you can see like 16 will give root 16 equals 4. ठीक है, so the value of r जो आपको यहाँ से निकलेगा, which is minus 1 plus minus 4 by 2. So which is either 3 by 2 or minus 5 by 2. And which was precisely one of the option you see 4 comma 3 by 2 that we have got from this analysis, right? So यहाँ से with the first term 4, I have two possibilities, either 3 by 2 or with 4 I have minus 5 by 2. With 4 minus 5 by 2. वो आप चेक भी कर सकते हो, because 4 से if I'll take let's say minus 5 by 2, I'll get minus 10. And again you take minus 5 by 2, so we'll get 25. And now you can see clearly 29 minus 10 is going to be 19. So this still is in GP, this still is a GP whose sum of 3 terms is going to be 19 with R is a rational number. So that is very interesting result. Next we'll try with let's say 9. Okay, so 9 indeed again you can check 9 is working, and 9 will give you values of 2 by 3 and minus 5 over 3. Next we'll check with 16. So you can see like 16 will not work, so that will be discarded. That you can see just by plugging the values. 19 se we'll get again 19 comma 0 and 19 comma minus 1. Right, 25 se we'll get 25 comma minus 2 by 5 and 25 comma minus 3 by 5. So 19 is not all. 19 is giving two answers, in which 19 comma 0 will discard. Ab dekho, the reason why we are discarding is it will give 19 as first term and common ratio 0, so it's 0. What about next term? So in fact if I take first term as a and multiply with r, so I'll get ar. Again if I multiply, so we'll get ar square. So according to this I am getting 19 0 0. But again it is controversial, because some of you might tell common ratio is ratio of successive term. So we are taking 0 by 19 is 0, but whatever 0 by 0 is should be not defined. So in that sense, although their sum is 90, if I define common ratio as the product of the previous member, then this should be accepted. But if you see the ncert definition, they have defined the ratios to be constant and non-zero. So ratio non-zero they have mentioned, तो इसीलिए हम इसको discard कर देते हैं. Okay, so final answer is 1, 2, 3, 4, 5, 6, 7. So there is such 7 GP in the set. So F contains 8 GP is wrong. F contains 4 GP. This is also wrong. Third option is correct. There exists some A1R such that first term and last term का product is 24. ठीक है, तो 4 term तो आप ऐसा ला ही सकते हो जहाँ पे 24 आ जाएगा, because now I have already GP. You can just write some terms whose first term and 4 term का product is 24. ठीक है, जैसे 4 और 3 by 2 से ही अगर if we'll check 4 and 3 by 2, so if we'll check, so first term is 4, second term was how much, 6, third term was 9, again fourth term will be, you get 27 by 2. So see, the first term and fourth term, if we multiply, we'll get 54, right? Yeah. I see, you can try with the other GP also, and you will see even the fourth option holds true. Right. So the correct answer of this problem is C and D. I hope you have enjoyed this problem, and if you want this kind of problems, please subscribe my channel and ask your friends also to do so that you get the actual quality content for free.